3 axis system, the x, y and z. Okay. Let us have the local axis x m, y m, and z m. Let us also have the transformation transformed axis y beta and z beta. This is y beta, this is z beta, okay. And this will coincide with x. Okay. So, now let us say this is my line of sight. I see this from here, where the member is placed somewhere here. Member is placed here. This is my jth end, my kth end, this is my member. Okay. This is my jth end, my kth end. Okay. So, let us say this angle is actually beta, and this angle is actually alpha, and this is y z x transformation. So, we did rotation first step, then rotation second step, then rotation third step, y z x transformation. Okay. So, the angle obviously this will be beta, and this becomes my z beta as well as z alpha. So, the angle between y beta and y m is psi y. The angle between z beta and z m, is it not, is also psi y. Now, if you try to draw a rectangular cross section of this member, seeing from the line of sight here, seeing from the line of sight here. So, let us say I am trying to draw it here. Let me draw the axis So, this is going to be my y m axis, this is going to be my z m axis, is not it? When I see from here I am seeing through. So, this becomes my x m, y m is vertical and z m is to the left, correct, you can see here left, and y m is to the right. Okay. Let us now mark y beta and z beta. So, this is y beta, this is z beta. So, the angle between y beta and y m or z beta and z m is called psi y. Okay. So, now we can write the angle psi y is measured anti-clockwise when viewing the cross section of the member towards the jth end from the kth end. When you see from here, you will see y m is to the left of y beta and z m is to the left of z beta. Okay, that is what we have marked here. So, the direction cosines that is C x, C y, C z actually define the location of x m axis, psi y defines the location of minor principal axis. In the transformation, all parameters are geometric dependent. Okay. Similarly, if I try to do this for z y x transformation, let us do this for z y x transformation. Let us say the reference axis is marked in red color. Let us mark the local axis in blue color. Z m axis. Let us also mark the transformed axis of y alpha, sorry, y lambda and z lambda. If this is x, we know that z and z theta will be same and the angle psi z will be measured between y lambda and y m. Similarly, z lambda and z m. If we start viewing this by marking a member with j and k end, The angle between this is actually theta and this angle is lambda. So, let us view the site towards this direction. Now, I draw the cross section. I mark the local axis ym vertical, because xm looking through, ym is vertical, okay, ym, and zm is to my left. So, zm is to my left and y alpha is to my right, okay, of ym. So, y alpha and z alpha. Y lambda and z lambda. So, now this angle is psi z, this angle is also psi z. So, psi z is measured anti-clockwise from y lambda towards ym or z lambda towards z as shown in the figure. Okay. So, we have equations now to compute these psi angles, which are very important. We will take up a numerical in the next lecture and try to explain how the psi angle can be computed for different set of problems. So, friends, as a summary, we have seen two set of transformations. In fact, they are actually rotations. One is y z x transformation, other is z y x transformation. In both cases, the last rotation is about x axis. The principal objective is to align x y z axis system along with x y z axis system, which is local. So, we need two issues, one is the direction cosine, which can be computed from the angle of rotation. Second is the psi angle, whether it will be y or psi z, depending upon whether we do y z x transformation or z y x transformation. The equations are available, figures are clearly drawn. I wish you will be able to understand this and estimate these angles for a given example problem, which we will discuss in the next lecture. Thank you very much.